Today we're going to tackle about the origin of the universe, the birth of the Big Bang theory, and the evidence for that theory. In the beginning, the Earth was flat. At least, it appeared so to its first observers, hunters and gatherers, and members of early civilization. Not totally unreasonable, one would think, because the curvature of our planet's surface is not immediately apparent. Yet we know, and it must have been not totally inconceivable, even to the Arctic tribesmen, that our senses occasionally deceive us. The Earth being flat brings back the problem that it must end somewhere, and last we imagine is to extend infinity. Infinity is a rather unfathomable conception, and hence, right down to the Middle Ages, people were afraid of the possibility of blowing off the Earth's boundary. The most popular theory of our universe's origin centers on a cosmic catalysm unmatched in all of history. This is the Big Bang theory. This theory was born of the observation that other galaxies are moving away from our own at great speed in all directions, as if they had all been propelled by an ancient exclusive force. The universe we can observe is finite. It has the beginning of space and time. Before which the concept of space and time
our universe, the galaxies, the solar system, our home planet Earth, land, sea, air, and life itself. Where did it all come from? If you look up into space from our planet, you'll see a vast cosmos teeming with billions of stars and galaxies. But turn back the clock 13 billion years, and our universe was so small it could fit inside the palm of your hand. From this infant universe, everything would be created. The stars, the galaxies, and the building blocks of life itself. The calcium in our bones, the iron in our blood, the atoms for the air we breathe, the water we drink, and the raw materials for building our cities and machines. We're about to take a journey through space and time to discover how the universe was born, how it created everything in our world today, and how eventually made of matter, atoms and molecules. This 1956 Ford Fairlane convertible is constructed from many different materials, including steel, rubber, and glass. These materials are made up of combinations of elements like iron, silicon, chromium, and carbon. And each and every atom that makes up those elements was created by our growing universe. Physicist Lawrence Krauss studies how the atoms we find on our planet today came to be here.
We really are part stardust and part Big Bang dust. Most of the atoms in our body are from the cores of stars, but some of them have been around since the earliest moments of the Big Bang. So we really are truly cosmic individuals.
Each and every atom was created over billions of years as our universe evolved.
So when we look at this car, of course all the atoms in this car came from stellar explosions, from supernova processes, and from stellar evolution. But they were created at different times during the evolution of the universe.
To understand how the universe made the raw materials on Earth today, we're about to take an incredible journey and travel back to the moment our universe was born. In the beginning, there was nothing, no space and no time. Then there was light. Suddenly, a tiny speck of light appeared. It was infinitely hot, and inside this tiny fireball was all of space. This was the beginning of time. The cosmic clock then began to tick. Time could now flow, and space could expand.
At the earliest moments of the Big Bang, if you take it back to t equals 0, everything in our universe, everything we can see, all the matter and all the energy in all of the galaxies was once contained in a region smaller than the size of a single atom today.
The idea that our universe was once tiny came from the brilliant work of American astronomer Edwin Hubble. Back in the 1920s, most astronomers believed that anything visible in the night sky was a star, and that all stars were part of our galaxy, the Milky Way. But Hubble wasn't convinced. He began to study a swirling cloud of lights called the Andromeda Nebula, and eventually showed that it was a star city, another galaxy far outside our own. He also showed that other galaxies were speeding away from ours, and the further away they were, the faster they seemed to be moving. The universe was therefore expanding. And if this were the case, then at some point in the past it must have been much smaller. And it must have had a beginning.
About 12 to 15 billion years ago, in a violent explosion. For an incomprehensibly small fraction of a second, the universe was infinitely dense and infinitely hot fireball. A particular form of energy that we don't know yet suddenly pushed out the fabric of space-time in a process called inflation. Inflation which lasted for only 1 millionth of a second. Thereafter, the universe continued to expand, but not nearly as quickly. The process of phase transition forms out the most basic forces in nature. First, gravity, then the strong nuclear force, followed by the weak nuclear and electromagnetic forces. After the first second, the universe was made up of fundamental energy and particles like quarks, electrons, protons, neutrons, and other less familiar particles. About 3 seconds after, the Big Bang nucleosynthesis cells in which protons and neutrons beginning to form a nuclei of simple elements, predominantly hydrogen and helium, yet for the first 100,000 years after the initial hot explosion, there was no matter of the form we know today. Instead, radiation, which it is called light, X-ray, and radio waves, which has dominated the early universe. Following the radiation era, atoms were formed by nuclei, linking up with free electrons, and thus matter slowly became dominant over energy. It took 200 million years until irregularities in the primordial gas began to form. Gas in a spiral arc of the Milky Way galaxy, roughly 5 billion years ago. A vast disk of gas and debris swirling around the early sun gave birth to the planets, including the Earth, which are our own planet, which is between 4.6 and 4.5 billion years old. This is most widely accepted cosmological viewpoint. So,
we're in the aftermath of the Big Bang. Everything we see and hear and taste and smell and touch is the aftermath. The Big Bang is really our evolving, expanding universe. For us, mostly stuck on our rocky little planet, the view of the universe begins with Earth. This is Earth, silicon and oxygen-based, with a metallic core. The surface is mostly water. It teems with life and rotates once every 24 hours while orbiting a star called the Sun every 365 days. This is the Sun, mostly hydrogen and helium. Its surface temperature is nearly 10,000 degrees Fahrenheit. For energy, our Sun converts 700 million tons of hydrogen into 695 million tons of helium every second. The Sun is part of a solar system formed around 4.5 billion years ago that includes Earth and 7 other orbiting planets from Mercury to Neptune. And it isn't a stationary system. Our solar system is spinning, flying through space at 134 miles per second, turning in circles as part of a vast collection of stars and star systems. There may be 200 billion stars in this collection called the Milky Way galaxy. An estimated 6 billion of those stars with planetary systems like ours. Our solar system orbits the center of the Milky Way on one of its outer arms. The Milky Way is one of more than 125 billion galaxies that make up the visible universe. This is the universe. It's really, really big. And it's getting bigger. It's expanding. If the universe is expanding, then it used to be smaller. Much smaller. In fact, if we went back in time, we could watch it shrink. Back far enough, and the universe would be smaller than a galaxy. Back, and the universe is smaller than our solar system. Farther back, and everything that exists fits inside a stadium, a coffee cup, an atom. 13.7 billion years ago, the universe was smaller than the smallest part of an atom. Unbelievably small. Then, something happened. In a flash, everything suddenly expanded. This was how it all began. The first moment of existence. What we now call the Big Bang.
And that's what we know.
Big Bang Theory. What about God? Any discussion of the Big Bang Theory would be incomplete without asking the question, what about God? This is because cosmogony, which is the study of the origin of the universe, is an area where science and theology meet. Creation was a supernatural event. That is, it took place outside of the natural realm. This fact begs the question, is there anything else which exists outside the table? This fact begs the question, is there anything else which exists outside of the natural realm? Specifically, is there a master architect out there? We know that this universe had a beginning. Was God the first cause? We won't attempt to answer that question. We just ask the question.